Hi everyone, let's continue to calculate the following vectors. So let u be 3i minus j minus 6k, and v equals 2i minus 4j plus 5k, and w equals minus 2j plus 3k. So part A, we want to find 4u minus 2v plus 3w plus 2u. Okay, so first step we look at can we simplify this expression? Are there like terms? Yes, there is. Can you see the u? For u and the 2u we can simplify. So let's simplify it. This is 4u minus 2v. So we get rid of the parentheses, then we need to distribute the negative. So minus 3w and then minus 2u. Okay, so when I print the worksheets, the UVW for the vectors, I can bold it. But for our handwriting, we must write the arrow on top of a letter to denote vectors. Oops, I forgot to write it here. Okay, so now we can combine the vector u together. We get 2u minus 2v minus 3w. So after we simplify the expression, we can go ahead and plug in the vectors. So u is, I like to use the components form. So this is 3 minus 1 minus 6. The v is 2 minus 4 and 5. So w, you don't see any I there. So it means the first coordinates is 0. And then we have minus 2 and 3. Okay, so let's see. So let's look at the first component. 2 times 3 is 6. And then we have minus 2 times 2. Okay, so we're looking at the first component of each vector, right? Minus 2 times 2 is minus 4. And 0 times whatever is 0. So this is the first component. Then we look at the second component. The first vector, we have minus 2. Second vector, minus 2 times minus 4 is 8. The third vector, minus 3 times minus 2 is plus 6, right? And then the last component, 2 times minus 6 is minus 12. Negative 2 times 5 is negative 10. Negative 3 times 3 is negative 9. Okay, what are they? 6 minus 4 is 2. Minus 2 plus 8, 6. 6 plus 6, 12. Minus 12 minus 10, minus 22, minus 9, so minus 31. Do you have the same answer, everybody? Yes, good. Let's continue. So part B. So I strongly recommend you to stop the video here and try to work on these problems. And then after you're done, you can continue to play the videos and check our answers together. Okay, so first let's figure out what is the vector 3v minus w. 3v, v is 2 minus 4, 5. W is 0, negative 2, and then 3. Okay, 3 times 2 is 6, minus 0, right? 3 times minus 4, negative 12, minus negative 2, so plus 2. 3 times 5, 15, and then minus 3, right? So we have 6. Minus 12 plus 2, minus 10. 15 minus 3, 12. So far, so good. And then what is the magnitude of it? The length equals the square roots each component square. Alright, 6 square 36, 10 square 100, 12 square 144, and add them up together. Okay, so 136 plus 144 is 280. So far, so good. And when we divide it by 4 is 70. So this is the same as 2 times square root of 70. So far, so good, everybody? Do you have the same answer? Good. Let's continue. Find the vector z such that, so we have this vector equations. We want to solve for z. So how it works is very similar to what we have done before, right? You want to move the terms with z on the left hand side, and you want to move the terms without z on the right hand side, and then you want to solve for z, right? So here let's add 5z on both sides. Then we have 7z minus 5v plus 3w equals 4u. And then let's move these guys to the right. But when we move, we change the sign. So it's 4u, and then now it's plus 5v minus 3w. Okay, what is z? Both sides divided by 7. So 4 over 7u plus, or it's better to do 1 over 7, and then we have 4u minus 5v minus 3w. Okay, now we have this expression. We can go ahead and plug in the numbers. So for u is 3 minus 1 minus 6. 5v, v is 2, negative 4, and 5. 3w, w is 0, minus 2, 3. Okay, now let's see what is this guy. So for the first component, 4 times 3 is 12. Then minus 5 times 2 is 10. Minus 3 times 0 is 0. Okay, second component, 4 times minus 1 is minus 4. Minus 5 times negative 4 is plus 20. Negative 3 times negative 2 is plus 6. And then we have the last component. 4 times negative 6 minus 24. Negative 5 times 5 minus 25. Negative 3 times 3, oh, minus 9. Such a big number, right? And, oh, we don't need the parentheses. Okay, let's continue. What is this guy? So, let's see here. Oh, I just realized I make a mistake. So here it was plus, but how come I make it to minus? So yeah, it's very important to check our work. You see, I find my mistake here, and then it changed everything. Okay, so let's see. And here we have plus 25. Okay, now we fix it. So the first component, 12 plus 10 is 22. And second component, minus 24 plus 6 is minus 18. And then we have 1 minus 9 is negative 8. So final answer, 22 over 7 minus 18 over 7 minus 8 over 7. You see, I divided by 7 at the last step because I don't want to work with fractions. Okay, so it's good to work with integer, and then you just divide it by 7 at the end. Do you have the same answer, everybody? Okay, so don't forget to check our work after we're done. Alright, let's continue. Here we want to find the vectors u, v such that, okay, so we have systems of linear equations. So the way how we solve it is very similar to what we did before, right? Let's write it down. Here we have 2u minus v equals 5i plus 8j, 3u plus 4v equals 2i minus 7j, right? So here we have like system of two linear equations, And we have two variables, u and v, we want to solve for it. So we can use substitution method or elimination method. Usually for linear system, elimination method is easier. So we want to eliminate either u or v. So which means we want to find the least common multiple of their coefficients. Well, the least common multiple of u is 6, right? Then you have to multiply the first equation by 3 and multiply by the second equation, the 2. And then to eliminate v, we just need to multiply by the first equation by 4, right? So that is easier. So let's eliminate v. Okay, so the first equation multiplied by 4, then we get 4 times 2, 8u minus 4v, 4 times 5, 20i, 4 times 8, 32j. And then how do we cancel the v? We use equation 2 plus equation 3. So when you're solving system of linear equations, please write down the operation, what you are doing in each step, and also label the equations, okay? So 2 plus 3, 3 plus 8 is 11, 11u, and the v cancel. 2 plus 20, 22i. 32 minus 7 is 25. J. So u is then both sides divided by 11. We get 2i plus 25 over 11j. Right? After we figure out the u, then we can plug in, well, we can plug in either equation 1 or equation 2. Looks like plugging in equation 1 is easier. Then, okay, we can also solve for v first, okay? So if we solve for v first, so v, you can see we can move the 2u to the other side, and then we can so let's see, we move the 2u to the other side, become minus 2u, and then we have plus 5i plus 8j, and then both sides multiply by negative, we get v equals 2u minus 5i minus 8j. Now we can plug in the u here. So then we have 2i plus 25 over 11j minus 5i minus 8j. So this is 4i minus 50 over 11j. Oops, plus. And then minus 5i minus 8j. Okay, 4i minus 5i is negative I. Okay, so, well, here is the same as we take the common denominator 11. Then this is like 50 minus 88. Well, that's negative 38. So negative 38 over 11j. Okay, so that's why we have solved u is 225 over 11. I love the component form, then I don't need to write the I and j. Okay, and this is negative 1, negative 38 over 11. So far, so good, everybody. Of course, you can put the I and j here as well. You can use either way to express it. Alright, so you have the same answer. Let's continue. Suppose v equals 7i plus 3j minus 6k. Find a vector that is oppositely directed to v and of length 13 times 9 units. Okay, so what we're doing, this is v, and what we're looking for, we want to find a vector that is oppositely directed to v, so it's the opposite direction, and the length of that is 13 over 9 units. Okay, so remember, a vector is, we can think about, is the magnitude times the direction. Okay, so for the direction, we can use a unit vector to denote. Okay, and here we already know the length is 13/9. So we just need to find a unit vector in the opposite direction of v. Okay, so do you remember how we find it? That direction unit vector is -v over the the length of v, right? So v is 7, 3 minus 6. What is the length? 7 squared, 49. 3 squared, 9. 6 squared, 36. Well, that is, let's see. Okay, so the answer is 94. Okay, so that's why we have 7, 3 minus 6, and that is square root of 94. So far, so good, everybody? Okay, so that's why our vector equals 13/9 times negative. So negative, we can think of 1 over the square root of 94, and then we have 7, 3 minus 6. Okay, so we can distribute it, multiply each component by the scalar. So 7 times 13 is 91. So 91/9 is square root of 94. Second coordinates, 3 times 13 is 39. 9 is square root of 94. Last coordinates, minus become plus. And so 6 and 9, we can cancel the 3. So we have 3 square root of 94, and then we get 2 on top of it. So 2 times 13 is 26. So far, so good, everybody? Do you have the same answer? Okay, yeah, the number could be complicated. Okay, let's continue. Find scalars a and b such that u equals av plus bw, where u is -1, -47, v is 3, -5, and w is 11/6. So in this way, it's better to use, so for this kind of problem, you want to express u as a linear combination of v and w, it's better to use column vector. Okay, so let's write it down. U equals AV plus BW. U, we use column vector to denote. So -1 minus 47 equals A. V is 3 minus 5. W is 11/6. Okay, so we use the column vector expression. Let's use brackets. Okay, for a matrix we can use parentheses or brackets, but when I write down, usually the notation, so we know a column vector could be A1, A2, AN, right? But if there are only 2 components, usually this notation, this notation is usually for combination. Have you learned like permutation and combination? This guy is usually denote the combinations 8 to 3, and this is calculated as you start with 8 and you multiply, you count down to 3 numbers, and then you divide it by, you see the 3, so it was 3, we count down 3 to 1. Okay, and 3 and 2 cancel the 6, so this is 54. So for notation, parentheses and then 2 numbers usually denotes for combination. So that's why I changed them to brackets. But in general, you can use brackets or parentheses to denote matrix. Okay? Or column vectors. Okay, let's continue. Okay, so what does that mean? Well, we can look at each component, right? Well, look at the first component. We have -1 equals 3a plus 11b. Second component, -47 equals -5a plus 6b, right? It's the same as a system of 2 linear equations. We want to solve a and b. Well, we can use the elimination method. We can choose to eliminate a, or we can choose to eliminate b. Which one is easier? The A looks like easier because the least common multiple is 15, but the B, the least common multiple is 66. Well, that's too large, right? So we denote this equation 1, equation 2. Equation 1, we want to multiply by 5. So, and I also want to move the constant on the right hand side. So then we have 15a, 5 times 11, 55b, 5 times -1, -5. Okay? And then second equation, we want to multiply by 3. Then 3 times -5 is -15a. 3 times 6, 18b. 3 times -47. 3 times 7, 21. 3 times 4, 12. So 141. So far, so good, everybody. Okay, so we call them equation 3 and equation 4. How do we get rid of a? We use equation 3 plus equation 4. Okay, so don't forget, please write down the steps and the operation you're doing when you solve the system of linear equations. So when we add them, a get canceled. 55 plus 18 is 73b, right? And here we have 146. Good. How do we solve for b? Well, b is just -146 divided by 73. Well, that's exactly -2. Okay, good. After we find b, we can plug in either equation 1 or equation 2. Equation 1 looks like easier. So 3a plus 11 times 2, so -22 equals -1. Then 3a equals both sides plus 22. Well, that's 21. Well, then a is 7, right? Now we have figured out a and b. Then what is u? Well, finally, u is then a. A is 7, v, plus b. B is -2, w. So this is our final answer. See, we have expressed u in terms of a linear combination of v and w. And in fact, we can always do that in R2. Okay, so if you have taken linear algebra, maybe you have heard the word linear independence. So in R2, 2 linear independence can generate R2. Then any vector in R2 is a linear combination of those linear independence vectors. Okay, so they also form a basics for R2. But in R3, we're gonna need 3 linearly independent vectors to generate a basics. Okay, then for any vector in R3, we can express that vector as a linear combinations of the 3 vectors in the basics. Okay, so that is section 11.1 and 11.2. We talk about vectors and the length of vectors, and we also do some vectors operations here. Okay, if you have questions, feel free to print screen and ask me in class or office hours or email me. Have a nice day. Bye.